Here's an example of a common ion effect problem, and I'm going to piece this out as we go, but we are going to calculate the pH in 3 different ways. The first thing I'm going to do is I'm going to calculate the pH of the base itself, which is this trimethylamine, and then I'm going to calculate the pH of just the salt solution, which is this solution right here. And then I'll actually do the common ion effect, just so we can see what happens with each of these. These two literally are the last chapter, so there's not going to be anything new in the calculation of A and B. But it's also good review for us. So, piecing this out, I'm just going to do part A first, which is looking at the pH of just the base solution. Okay, so I have this base of trimethylamine, and the first thing we need to do is write out that reaction in water. So I chose this one just because it's kind of a weird formula. And we're going to react that with water. Okay, and this is going to be a base. And the thing with this is, this has no hydrogens to donate. All of these hydrogens right here are actually bound up and pretty locked into that carbon atom, so they're not going to be free to donate. So that means the donor has to be the water molecule, okay? That has to be what donates the hydrogen. So if that's what donates the hydrogen, then what we're going to get is CH3, 3NH plus OH minus. And therefore, because we have that OH minus, we know that this is a base. And I do need you to get used to seeing, hey, I have OH. That's going to become a factor in this next chapter, that I have a base. Now, the end result of this is we need to create an ice chart. Okay, I have 0.075 moles of that. That doesn't matter. I have 0 and 0. And this is just our good friend ice charts, where we're going to subtract X and X because I essentially know the KB. So this is going to be 0.075 minus X, X, and X. So this is going to be an equilibrium constant expression where the KB is going to equal X times X all over 0.075 minus X. And the KB is 6.4 times 10 to the minus 5th. That's going to basically equal X squared, or X times X, all over 0.075 minus X. This is 10 to the minus 5th, so that X doesn't matter. And now you can do the math here and solve for X. And I actually want you to do that. Pause the video, solve for X, making sure you're doing that correctly. X here comes out to be 0.00219. And then you just need to remember that that X is the OH minus concentration. Okay, go back to our chart. X is the OH minus concentration. So, when I calculate the P, the first thing I'm going to calculate from X would probably be the POH, okay, which would be 2.66. And then from the POH, I can find the pH, which is 11.34. And I've made a lot of assumptions here that you know how to get this and this. Okay? If you don't, you should probably email me and we should talk. So the second part of this then is this is the salt solution. Now, how do you know that's the salt solution? Basically because it has that chloride in it. So it's trimethylammonium chloride. That's how you know it has the salt solution. So what's going to happen, if this is the formula right here, the chloride isn't going to matter and that's going to ultimately be a +1 charge. So what we're going to have in this particular reaction is going to be our same CH3 and H, okay, oops, but that's going to be a plus H2O yields, okay, so the chloride doesn't matter, which is why I left the chloride out of that expression, but now this has this extra hydrogen which can donate to the water, so you're going to get H3O plus the CH3N, okay? And then notice, and this is difficult, but notice that is the original base, okay? Now, it doesn't mean this is a basic substance because we have this acid right here, okay? But we have the original base back, okay? Things that you need to note. This becomes an ice chart again. And remember, we are now just doing the pH of just this solution. So this is 0.1. Water doesn't matter. 0, 0. Minus X, X, X. 0.1 minus X, X, and X. But this is an acid, okay? So this is going to be a Ka, which is going to equal X times X all over 0.1 minus X. And the Ka was given, so that's 1.56 times 10 to the minus 10th equals X squared all over 0.1 minus X. That X doesn't matter. Solving, I'm going to let you pause the video and solve for X on your own. But solving for X gives us 3.95 times 10 to the minus 6th. And X now is H3O plus. So then I can just find pH directly from that. And that pH comes out to be 5.40. Okay? So you can see with these last two problems that the base over here, the base produced a basic solution. The salt of that base produced an acidic solution. Okay? Now, the question becomes, what's going to happen when we mix those two solutions together? Okay? So, part C of this is, what is the pH when the above two are mixed together? And this is where it gets a little tricky with, okay, what equation do I use? And the equation that you're actually going to use is the equation of the original base. And that's going to be something that's in this chapter that we are going to have to get used to. So there's the equation that's going to come out of this. The water is going to be the donator. And this is your base, and the reason why you use that, and this is the salt of your base. Okay? And that's what you need in your equation. So then we're going to ice this. But this is now our common ion effect problem. So I have 0.075 moles of this. Water doesn't matter. But I also have 0.1 moles of that. Okay, which is going to cause this reaction basically to shift back to the left. And I have 0 of that. So this is going to be minus X, X, and X. So this becomes that, and that. Now, you do need to recognize, is this an acid or a base? Okay? And because we have that, we are a base. So that means we're going to be using the Kb. So the Kb is 0.1 plus x times x all over 0.075 minus x. Okay? And then using the KB of this is 6.4 times 10 to minus fifth. That equals 0.1 plus x times x all over 0.075 minus x. And again, we have that 10 to the minus fifth, so I can eliminate that x, and I can eliminate that x. Now, from there, solve. And again, pause the video to solve. I'm not going to do that. And this is going to give you an x of 4.8 times 10 to the minus fifth. Okay, and then from that, you need to realize that that is the OH minus concentration. So if you use that to calculate POH, that is going to give you a POH of 4.31. And that's assuming I can read my handwriting correctly. The pH then comes out to be 9.68. And that number I know is absolutely correct. So now if you look at that pH, it's somewhere between the high of just the base or the salt by itself and the low just the base by itself. And no, it's not an average. Okay, so that would be another example of how to solve a common ion effect problem.